A sample of a compound containing only carbon and hydrogen is burned, producing 0.528 grams of carbon dioxide and 0.162 grams of water. What is the empirical formula of the compound? Okay, so we're trying to figure out the empirical formula of a compound containing only carbon and hydrogen. So if we can get ratio, we would have the empirical formula. Now, the way that we learned to find out empirical formula in class is that we need to find the moles of carbon and hydrogen. Well, we need to find the moles of each individual compound, each individual element in the compound. Yeah. And in this problem, how do we achieve that? What we have are combustion products. Yeah. But we all know that burning in air means reacting with the oxygen in air. Yeah. And that means all the carbon inside carbon dioxide is coming from this compound, and all the hydrogen in the water produced is coming from this compound. We know the amount of these compounds. We can certainly figure out how much of carbon, how much hydrogen are there. Let's do that. So 0.528 grams of carbon dioxide, and carbon dioxide is molecular weight 44.01 grams per 1 mole. And gram cancel, we would have mole of carbon dioxide. We don't need mole of carbon dioxide. So let's get rid of that. And we do want mole of carbon. And lucky for us, it's a 1-to-1 ratio. So this should be pretty easy to do. The calculation result shows that we have 0.0120 mole of carbon in the compound that was burned. Okay, now next, 0.162 grams of water. Same thing, different molecular weight. 18.02 grams of water is 1 mole. But we don't want a mole of water. That doesn't help us. 1 mole of hydrogen. Now, watch out. Don't forget that little subscript. 1 mole of water has 2 moles of hydrogen in it. Alright, so that's going to give us the number that we need, which is 0.0180 mole of hydrogen. Now we have both the mole of carbon and hydrogen, and now it's easy. The smaller number of moles is apparently 0.0120, so we're going to divide both numbers by the smaller number. For carbon we get 1, for hydrogen we get 1.5. Since we can't use fractional numbers as subscripts, we need smallest whole number ratio, so we need to double up that, and if we double up 1.5, we need to double up 1 as well. So this is 2 for carbon, 3 for hydrogen, and the empirical formula of this compound, the ratio between carbon and hydrogen, is going to be 2 to 3. The compound would have an empirical formula of C2H3. That would be the correct answer. Now, so whether we're dealing with amount of the element inside a compound, or if we're dealing with a combustion product, the idea is the same. We need moles of each individual element inside a compound to get the empirical formula.